Okay, so just 2C to start off with. So suggest. So it means we're going to take the knowledge that you have and try and apply it to an unfamiliar situation. So suggest why the temperature of a mammal is maintained just below the optimum temperature for the enzymes in that mammal. So this is the idea that, well, think about it if it wasn't. If the temperature of the mammal exceeded the optimum temperature for the enzymes, then the enzymes would denature, and therefore they would need replacing. Okay, so if we go on and look at the graph here, the first thing I would do with this would be to request a new piece of graph paper. The rate of reaction has been recorded as a proportion of its maximum activity. So construct a graph. So the axes that we're going to have is going to be our independent variable on the bottom, so it's going to be pH. You need to fit from 1 to 13 along there. Please note that the divisions between these are not equal, but they have to be spread out. So like 1, 3, 4, was closer. And on the y-axis, it's going to be the rate of reaction as a proportion of its maximum activity. So the units for that will be percentage. Lots of people just wrote salivary amylase percentage here. That would suggest to me that that was the concentration of salivary amylase used. It had to be the rate of reaction of the salivary amylase as a proportion of its maximum. So to within one point, one small square you've got to get for accuracy, and it tells you to join with a smooth curve. So this is not dot to dot in this instance. To get a smooth curve, make sure that you put your hand on the concave side of the curve. So the hand to draw like that would be up here, and same for the curve coming around this side, it's going to be up here as well. And you're going to need to go along the top, you need the hand inside there. The question then goes on to ask, use your graph to determine the activity of salivary amylase in the stomach. So if we look back to the graph, you can, well, it tells you the pH is 2, and between 1 and 3 it's 0, so it's got to be 0 that you'll get from your graph there. Draw a curve to indicate the probable pattern of the activity of the stomach enzyme pepsin. So it tells you that it's active in the stomach, so you must have an optimum pH of 2, and you will want to do a similar range to what you got for this curve. So if this curve was probably like that, then a similar range is probably going to be about between 1 and 5 to get credit for that. Okay, explain how a change in pH can affect the activity of an enzyme. Right, this is explain, not describe. So again, you've got to have that the extremes of pH, you'll have the acid and the alkali, the H plus and the OH minus ions binding to the protein and changing its 3D shape. So if we have a small change in pH, we'll have a small reduction in activity. If we have a large change in pH, then the enzyme is effectively denatured, so the substrate cannot bind to the active site. Two other things which must have been kept constant, well, if we look back to the investigation, they would change in the pH, so we can't have that one, but we could have temperature, we could have enzyme concentration or substrate concentration. What would be used to control the pH? That would be a buffer solution.